Hi, I am Professor John Barroso, and today we're going to learn about finding probabilities using the empirical rule. You have my information on the screen, and you can also see my YouTube channel. There's a bunch of other videos on statistics and math. So let's see how we can answer this first question here. How can we understand the normal distribution curve? Well, first, let's see some properties of the curve, okay? So the total area under the curve equals to 1. That's not only for the normal distribution. Any distribution in statistics has area equal to 1. So that's the first thing. The normal curve is centered at 0. That means the center of it is 0 and the standard deviation, okay, is 1. That means each step we take is 1. We go to the right, 1. We go to the left, 1. Okay? Let me draw a shape here, and that will be a little clearer. Here is the normal distribution shape. I'm making this line long on purpose because the distribution is actually somewhere like here. Now I cut it at this point and I say this is the center of it and the center is 0. Now this distribution goes to positive infinity on this side, negative infinity on that side, and every time I go one step, I say that the standard deviation is 1. I go one more, I am now on the second standard deviation on the right side, and I go one more, I am on the third standard deviation on the right side. Note, go back to the center again, and we take one step to the left. Now we went 1 to the left, the standard deviation is -1. I go one more. Now I am 2 to the left of the center. This is -2, and one more is -3. Now, the whole area is 1. Note that from this cut to this cut, we probably took up most of the area. Almost the whole one is between these two numbers. So the area from -3 to +3 is roughly, okay, I'll say -3 plus 3 is roughly 99% or 0.99. Okay, that's what the empirical rule says. Now, what is the area from the center, this center, to +2 or -2? This area that you see now with red lines. Well, the empirical rule says that from -2 to +2, it's roughly 95% or 0.95. Now, the last part we want to look at now is what is the area from -1 to +1. I'm shading it now. I'm talking about this area here. Okay, this area here includes both sides, of course. It's -1 all the way to +1, and it's roughly 68% or 0.68. Okay, that is the normal curve, and that is the empirical rule. Important thing, can you always use the empirical rule? No, because the empirical rule can only answer questions if the question says exactly 1 standard deviation, exactly 2, exactly 3. If the question says from 0 to 1.54, then you are stuck. You can't use the empirical rule. For these cases, you need the table. Okay, so the empirical rule is only for 1, 2, 3 standard deviations to each side. Now, being that I explained what the normal curve is, that's the empirical rule. It's answered here, and we can now look at the table to show you where these numbers come from, like the 68, 95, 99. That's what I meant by proving it. So we can see that our normal curve, I'll draw one here. I take the center. Let's say I mark 1 standard deviation. Okay, so what is the area from -1 to +1? Well, how can I find this in the table? Let's look at the normal table, which you have in your book. It should be similar to this. Some tables are different. Most tables work the way we have here. So let's look at our drawing. We see number 1 standard deviation, positive. So we'll go to the normal table and we find it right here. We can see that to 1 standard deviation, the number on the table is 8413. Now, it's important that you understand this part. You see the chart on top of the table, the blue part? That 8413 is integration from infinity, negative infinity, all the way to this line. This whole thing is 8413. So let's look at our drawing. What is 8413 then? Integration from all the way here to this line. Well, this is 8413. We're going just to round it to 84. Now, what you need to think of here is that this cut at the 0 is splitting the normal shape into 2 halves. So this half is obviously 0.50. So since that part is 0.50, how much is this part here? Well, the table says the whole thing is 84, so this part has to be 34. Now, since one side of 68, meaning one side of 1 standard deviation, recall that I said when we started that 1 standard deviation goes from the center, 1 to the right, 1 to the left. Okay, that's 68. Here we only went to the right, so it's 34, but we have the other half right there. So the other 34 is right here, and now we have the 68. Okay, so the table confirms the empirical rule that if I go 1 standard deviation to both sides, 1 to the right, 1 to the left, I get 68. Now, what if I say 2 standard deviation? Well, let me get another color here, and we're going to look at 2. Okay, so now in green, we go 2 to the right. We're going one side only. Maybe I should highlight here to help you see this. Okay, so what if now I go 2 standard deviations in green? Okay, I'm going 2 to one side only. All right, so if I'm going 2 to one side, then this, instead of 95, it's only half of the 95. Okay, so that will be 475. So the green piece is 475. And if I think of another green piece on the other side, I have the center 95. Okay, so this is 2 standard deviation. Let's take a look at the Z table to see what it says. We're going to look at number 2 now. And number 2 is showing 9772. Okay, so 9772, well, take half of it. Well, half of 9772 is roughly 475. Okay, that's because, again, like I said before, the book is integrating from minus infinity all the way to this line. So this is how the book integrates. So the book says that this is 9772. but it's all the way here. Well, the green area is just the right part of 2 standard deviation. So the green area is 9772 minus 0.5 or 0.50, and that's how we get 475. Okay, and if we double 475, we have approximately 95. Okay, so now that we understand these ideas, let's solve a little problem here. Let's see what this problem says. A study shows that the mean weight of American girls aged 19 is 131 pounds. So when we say American girls, we're talking about the population of American girls. We're talking about all the American girls. So we're talking about mu being 131. Okay? Now, we don't have a standard deviation, so we're going to assume 5 pounds. I am assuming this. The actual study did not show the standard deviation, so I'm assuming 5. And note, Greek letter. That means it's population values. So let's draw both shapes, and I recommend that you draw both shapes too. Many professors don't, and I haven't yet seen a book that draws both shapes. But let's draw both shapes, and here's what I mean by both shapes. I mean, there is an X number line where the mean is 131, and there is a Z number line where the mean is 0. Remember, I said that the standard deviation has a mean of 0. So these are the same curves, except that one has a Z number line and one has an X number line. Okay? Now, we also know that the standard deviation is 5, so on the X number line, we increment every step by 5. So this is 136. 131 plus 5, we go one more, and it's 141. And we go one more, and it's 146. Now, we have to go to the left. So we go down 5, and it becomes 126. We go down 5 more, becomes 121. And we go down 5 more, and it becomes 116. Now, the best way for you to remember this is that for every number on the X number line, there is a correspondent number on the Z number line. So you just do this. You draw a line straight down and mark 1. Okay? This is the first standard deviation to the right. Line down, mark 2. Now you went 2 standard deviations to the right. Mark 3. 3 standard deviations to the right. So the 1, the 2, and the 3 correspond to the 136, 141, 146. So now we're on the left side. Down below 126 is minus 1 because we're going to the left. Okay? Below 121 is minus 2, and below 116 is minus 3. Now we can answer the question. The probability that a randomly selected girl weighs less than 126 pounds. You have to say randomly selected. Otherwise, it's not probability. Okay? So, the girl is randomly selected. What is the probability she weighs less than 126 pounds? So, let's shade the area we want. Okay? We want this area. It doesn't matter where we shade, but I'm going to shade on both. We want this area. So now let's see how we find that area. Well, let's take the center. Always take the center, okay? Using the empirical rule, go to the center, go to the center. Okay? Now, you remember that if we go 1 standard deviation to both sides, we have 68. So one side only, we have 34. Okay? That 34, we don't want it. We want the green part. You also remember that this cut is right at the center, so the whole piece to the left is 0.50. The whole thing is 0.50. We don't want 34, so how much is it that we do want? Well, we do want 0.50 minus the 0.34, and we do want the 0.16. So the green area is 0.16 or 16%. Okay? So we could say, generalize to the population that 16% of all American girls age 19 weigh less than 126 pounds. Next question. What is the probability that a randomly selected girl weighs more than 136 pounds? Okay, so I'm going to draw all over again because I don't want to erase what I did there. We're talking about 136 pounds. So here's the center, 131. Here's 5 more, 136. 5 more, 141. 5 more, 146. The question is more than 136 pounds. So let me shade or highlight. This is what we want, this area. So let's count. We went 1 standard deviation, and we don't want that. We want this spot here. Now we also know that if I take the center, we always come to the center, and we go all the way to infinity, this whole part is 0.50. So it's the same logic we used before. The whole area is 0.50. I do not want the white part. How much is the white part? Well, the white part is half of 68. So here it's 34. I don't want it. What is it that I want? The green part. And the green part is the whole half minus what I don't want, that 34. And we got 0.16. So 16% of all American girls age 19 weigh more than 136 pounds. Next question. What is the probability that a randomly selected girl weighs between 126 and 141 pounds? You are going to get questions of this type because a lot of people get confused. There's a lot of mistakes happens in quizzes when you have to find these probabilities between using the empirical rule. So we're going to draw two shapes. The X number line, the Z number line. On the X, the center is 131. On the Z, it's 0. Here's the normal shape. Here's a normal shape. Now, the question is between 126, so let's find where 126 is. We go 1 down, we get to 126. So on the Z, it's minus 1. Let's go to the right now. 131. One more, you get to 136. One more, you get to 141. That's the number we want. So below 136 is 1 positive standard deviation and 2 standard deviation. Note, we want the areas between 126 and 141. So we are talking about half of 2 standard deviations plus half of 1 standard deviation. Okay, so I'm going to shade a little slowly here so that you understand what I mean here. I'm going over 2 standard deviations, but I'm going to one side only. So the piece I just shaded is half of 95. Okay, so it's 95 divided by 2, it's 0.475. This is this green shaded area. Now, I'm going to shade the other part And let me pick a new color here. Go back to highlighting yellow. I also want, let's make sure we have the yellow here. I also want this part. I want both parts because that gives me the weight between 126 and 141. This part, get back to the color here. This part is half of 68 because I went one side only. I didn't go both. Okay, so that is only 34. So now, girls weighing between 126 and 141 are in this shaded area, the yellow and the green area. We add both. So all we need now is to add 0.34 plus 0.475, and we get 5, 4, 3, 11, 1, and 81. Oops, something happened here, but I'll fix it. All right, 81. So this is the answer. Both areas together, answer in red is 81.5. Okay, you may get a question like this in the quiz, and very often in a class of 30, we get about 5 people getting the wrong answer. So you don't have to get the wrong answer anymore. You can get it right now. The last question now, what is the probability that a randomly selected girl weighs either less than 125 or more than 146? Okay, so let's draw this again because it's either or now. X number line, Z number line. On the X number line, the mean is 131. On the Z number line, it's 0. Here's the shape. The shapes are not perfect. I know that. So it's either less than 126. So let's go here. We go down 1 standard deviation. If you forgot, we're going down because the standard deviation is 5. Okay, and we are at 131, but we're going down 5. So we're going down to 126 if you forgot. Now we go up 5, we get to 136, and 5 more we get to 141, and 5 more we get to 146. Note, let's mark the z values for these numbers. -1 here, this is 1 standard deviation, this is 2, and this is 3. Now note, we want the probability that a randomly selected girl weighs less. So let me shade the last part, then 126. We want this, weighs less, or more. So when we say or, we are adding, okay? We are adding. So more than 146. So we're talking about this. Okay, so there is confusion and mistake in quizzes too, because many students will say that, hey, I added right, that white part is my answer. Wrong. That's what we don't want. Okay, so we want either less than 126, more than 146. So let's see what we want then. Here, I am going to the center of the Z, and once I get to this mark, I know that I don't want this, because what I want is actually sitting on this side. So that's what I don't want. Now, when I go to the right, I go all the way to 3, and I don't want that either. All right, I want that. So the best way here is to remember that the whole The whole thing is 1. So 1 minus what we do not want. Well, if I throw away what I don't want, I keep what I want. Okay? So I have to throw away what I don't want, which is the white area. So let's take a look now. I'll change color here so you see a little better here. Pick this color. I don't want this area. How much is this? This is 1 standard deviation from the center, but it's not really 1. It's half of 1. It's half of that 68. So this piece here that I don't want is 34. Okay. Now looking on the right side, let me pick another color here. I'll pick I don't know what color is this, but it's kind of red. I went 3 and I don't want this. So what is half of 3 standard deviations? Well, I went one side only. That's what I mean by half. I didn't go both sides. So when I go both sides, the empirical rule says it's 99%, but I didn't go both sides. I went one side, so I went half of that. Okay, so all we need to do here is to take half of 99% to find the size of that area there, and half of 99 will be 495. So I went one side, I went 495. So what are these numbers? These are the things I don't want. I don't want this, and I don't want this. So I have to throw them away. So here's the answer. 1 minus what I do not want. I don't want the 34 plus I don't want the 495. Those are the things I don't want. So 1 minus those two. The answer is 16.5. So we can now say that 16.5% of all American girls age 19 weigh either less than 126 pounds here or more than 146 pounds here. A little note before we leave, okay? Note, if you use a calculator, be sure to type 1 minus and type the parentheses because of the order of operations, okay? This 0.34 adds to this 495, and that's the right way. The wrong way is 1 minus 0.34 plus 0.495. This is wrong, okay? So don't forget to put your parentheses, and I wish you good luck. This was Professor John Barroso. And good luck on your studies. I hope you don't get these questions wrong anymore, all right?